We're going to talk a little bit about operations with functions. So if we let f and g be any two functions, a new function can be formed by performing any of the four basic operations. So in other words, if we have two functions, we can add them together, we can subtract them, we can multiply them together, or we could divide them. Notice it says for the division part, it says f of x divided by g of x, where g of x is not equal to 0, because if g of x is in the denominator, we don't want the denominator to be 0. So we could use the notation f, look at the notation, f plus g, or we could say f of x plus g of x. It means the same thing. So the domains, and this is very important also because we're going to talk a little bit about domain today. The domains of the sum, difference, product, and quotient consist of x values that are in the domains of both f and g. So we'll highlight that, both f and g. So when we're going to talk about the domain of f and the domain of g, and we have to know that when we add them together, or subtract or multiply or divide, then the domain of the new function we get is going to be the domain of what the x values that are in both f and g. The key word there is both. So in other words, where the two domains intersect. Okay, let's add two functions together and subtract. It says let f of x be 4x plus 7, and let g of x be the square root of x plus x. What are f plus g and f minus g? Okay, and what are their domains? So the first thing we're going to do is do f plus g. So f plus g would be 4x plus 7 plus the square root of x plus x. So we're just going to add like terms together. So we'll say f of x plus g of x is 5x plus the square root of x plus 7. Now let's talk about the domains. So the domain of f is linear. So we'll say the domain of f is the set of all real numbers. And g of x is not linear, it's a square root. We have a square root. So we know that the number inside a square root cannot be negative. So we'll say that the domain of g would be anything greater than or equal to 0. So the domain of this new function will be where the two domains intersect. So in other words, what the two domains have in common, what the x values that consist of both the domains of f and g. So in other words, that would be the domain of our new function. We'll put it in set notation, all x values such that x is greater than or equal to 0. All right, now let's do f minus g. So f minus g, we have to be careful because if we're subtracting more than one term, we have to make sure we distribute our minus sign. So 4x plus 7 minus the square root of x plus x. So that would be 4x plus 7 minus the square root of x minus x. So we're going to combine our like terms. So f minus g of x is 4x minus 1x is 3x minus the square root of x plus 7. And notice that the domain here is also anything greater than or equal to 0 because we have an x inside of a square root. And so we know that a number inside a square root can't be negative. Okay, so now we're going to multiply and divide. So we added and subtracted. So remember when we add and subtract, we only add and subtract like terms. So this is what we get when we add. This is what we get when we divide. Subtract. All right, so now we're going to multiply and divide. So we're going to let f of x be x squared minus 9 and g of x be x plus 3. So first we're going to find f times g, and then we're going to find f divided by g. So f times g is x squared minus 9 times x plus 3. So we know how to multiply. Since these are both polynomials, we know how to multiply them together. We'll do FOIL here, right? So we'll do first, outer would be 3x squared, inner, and then last. And we don't have any like terms. So here is f of x times g of x, or f times g. And now let's talk about the domain. The domain of f is quadratic. So we know that the domain of any polynomial is all reals. And so since f is a polynomial and g are both polynomials, the domain of both of these functions are all real numbers. The domain is all real numbers. And so therefore, the domain of our product, which happens to be a cubic, which is also polynomial, we'll say the domain is all real numbers. Okay, so there's f times g. Now let's do f divided by g. would be x squared minus 9 over x plus 3. So this is a function that can be simplified, but we don't want to have to worry about simplifying it. So we're just going to talk about the domain here. We're going to say this is f divided by g. We're not going to simplify. This is f divided by g. And let's talk about the domain. Well, since the g of x is in the denominator, we don't want g of x to be 0, do we? So we don't want our denominator to be 0. So we think to ourselves, what's going to make x plus 3 equal to 0? Well, it would be when x is negative 3. So we want to say that the domain would be all x values as long as x is not equal to negative 3. So that's what we're worried about when we're dividing, is we're worrying about the denominator being 0, because when you divide, you have something divided by something in the denominator. All right, let's do another example. We'll do one more. Let f of x be 2 minus x, and let g of x be 1 over x. We're going to perform the indicated operation, and then we're going to find the domain. So the first thing we'll do is we'll add. So we're going to add 2 minus x plus 1 over x, which we can go ahead and leave it like this. We don't want to worry about simplifying too much just yet. And also the domain, when I think about it, let's see. The domain of f is, well, f's a polynomial because it's linear. So the domain of f is all the reals. But what about g? The domain of g is not all the reals because we have an x in the denominator. So we know that for the domain of g, we don't want x to be 0. So therefore, for our domain of our sum, we want everything except 0. Notice the x in the denominator here. We don't want x to be 0. Okay, so let's do the same thing for f minus g. We're going to do 2 minus x minus 1 over x. That's all we're going to do there. That's f minus g. We're not going to simplify that anymore. And we're going to say that the domain, since we still have an x in our denominator, we want the domain to be anything except 0. Okay, now let's multiply. So we're going to do 2 minus x times 1 over x. So I'm going to distribute. So I've got 2 over x minus x over x, which is 2 over x minus 1, isn't it? Okay, so there's my f times g. And the domain, once again, everything except 0. So we're looking for if the domain of f was all the reals and the domain of g was everything except 0, then the domain of the quotient, the product, the sum, the difference, or the product will be what the two domains have in common. So what they have in common, everything except 0. And let's do one more. Let's do f divided by g. So I'm going to do 2 minus x over 1 over x. So we don't want to divide by a fraction. We want to multiply by the reciprocal. So that's going to be 2 minus x times x, which is 2x minus x squared. So f divided by g is 2x minus x squared. Well, this is tricky because we want to make sure we think about the domain of f and the domain of g when we talk about the domain, because our quotient looks like it's a polynomial. But actually, our original unsimplified version of f divided by g tells me that we want x to be anything except 0. So when we're talking about the domain of our quotient or our product or our sum or our difference, when we're talking about your answer, we want to always, for the domain, look at the unsimplified version. Because if we look at the unsimplified version here, we see that x cannot be 0.